Hello guys, this is Shyam from SS.Embedded world. Today I am going to explain you how to write a code on arithmetic operations of 8051 in Keil Microvision and create a circuit in Proteus simulator. If you don't have any of these two softwares, then here is a card for the videos for downloading the softwares and creating a new file in the softwares. Now let's get this video started. Firstly, take a look on the problem statement which we have taken, that is the arithmetic operations of 8051. Before getting into it, we need to know the arithmetic operations which are used in the 8051 microcontroller. So, the general arithmetic operations which are used in 8051 microcontroller are addition, subtraction, multiplication and division. Now, there are two registers which are mandatory while we use arithmetic operators. They are register A or accumulator and register B. The register A can be accessed alone, but the register B should always accompany with A. In arithmetic operations like addition and subtraction, the register B may be used or may not be used. But in the case of multiplication and division, both A and B are to be used together, and this is a rule. Now, let's see the syntaxes of these arithmetic operations. The syntaxes are very simple. Firstly, we take a look on addition. The syntax is add A, x, where this can be implemented as A is equals to A plus x, where x can be any of the general purpose registers, that is from R0 to R7, or the register B, or any direct value, or any address location of the value. Now let's take an example and see how it works. I have taken the value 0x05 in A and 0x03 in B. Now on implementing add A, B, the result 0x08 is calculated and stored in A. Similar to the addition, the syntax for subtraction is also same. The syntax is sub A, x. This is evaluated as A is equals to A minus x minus C, where C is the borrow bit or the carry bit. This C will be 1 if there is any borrow or carry in the previous operations. Now let's take an example and check this. Now I have taken the values 0x05 in A and 0x03 in B. On implementing sub A, B, the result 0x02 is calculated and stored in A. In the case of multiplication and division, both registers A and B are to be used. So the syntax is mul AB. Make sure that there is no gap or comma between A and B. Now let's take an example and solve this. I have taken the value 0x05 in A and 0x03 in B. On applying multiplication operation, that is mul AB, the product which is 0x0f, that is 15, is calculated and stored in A. There are some cases where the product result is greater than 8 bit, that is greater than 255. So in that case, the overflow bit in the PSW register will be set and the result is distributed as lower byte in A and higher byte in B. Let's take an example and check this statement. I have taken the value 0x10, that is 16 in both A and B. On applying the multiplication mul AB, the product result is 0x0100, that is 256. Since this value is greater than 8 bit, that is 255, the lower byte of the result 0x00 is stored in A and the higher byte of this result 0x01 is stored in B. In this way, the multiplication operation is written. Now let's see the division operation. The syntax is div AB. Now the results for the division are remainder and quotient. So whenever you divide a number with another number, the quotient is calculated and stored in register A, while the remainder is calculated and stored in register B. So let's take an example and check this out. I have taken the value 0x05 in A and 0x03 in B. Now on applying division operation, that is div AB, the quotient 0x01 is calculated and stored in A and the remainder 0x02 is calculated and stored in B. So this is how the division process is achieved. If you want to divide a number with 0, that is the divisor is 0, then the overflow bit in the PSW register is set and it indicates that the divisor is 0 and this division operation cannot be held. So in this way, the arithmetic operations are written in ALP. Now let's write a code in Keil with the help of these arithmetic operations. I have already written a code in Keil, so let's check it. In this way, the code has to be written in the Keil. Initially, I have assigned the ports of this 8051 microcontroller. In the first two lines, we can see that I have assigned the values FFH in P0 and P1. This means that these two ports are acting as input. In the next two lines, I have assigned the value 00H to port 2 and port 3. This means that these ports are taken as outputs. So after assigning the ports, we have to take the inputs and we have to apply the operation and store the result in the registers. So I've taken the inputs from 2 ports and stored them in A and B registers. Now I've applied the addition operation, that is add AB, and the result is calculated and stored in A. Now when we use this accumulator for the next operation, the result which is stored in A will be discarded. So in order to avoid that, we have to store this result in some general purpose register. So I have stored the result of addition in R0, and for showing the result as output, I have redirected this value to the port 2 for showing this as output. In the similar way, the remaining operations are also done, taking the inputs, calculating the difference, storing the difference, and giving it as output. So in this way the code is written. Now let's check this code for errors. For doing so, we have to debug this code. So click on this tool in the toolbar and the debug starts. We can see that there are no errors and no warnings. So this means that our code is error free. Now let's check the execution process of this code. This can be done in the debugger. So in order to do so, open the debugger and start debugging. Here you can see that initially all the ports are assigned with FFH value. This means that 8051 defaults all the ports as inputs before we assign the specific port. Now let's start the debugging. Place the cursor at the first line and press F11 for step debug. See, after the execution of these 4 lines, the ports P2 and P3 are assigned with 0x00, that is, they are turned as outputs. Now let's give some inputs in the port 0 and port 1. For doing so, just untick the boxes and give the desired value. I have given the first input as 5 and the second input as 3. Now let's place the cursor here and continue the debugging. See, after taking the inputs, we can see the A, B values are updated in the register tab. Now on implementing the next step, the result, that is sum of A and B, is calculated and stored in A. Now let's save this result in register 0. So the value is updated here, and let's show this result as output. So we can see that the port 2 is showing 0x08, that is the result of addition. In the similar way, the remaining are also done, taking the inputs, calculating the difference, storing the difference, and giving it as output. For multiplication, we took the inputs, calculated the product, and stored the product and given the product value as output. And so for the division, the values are taken, the remainder and quotient are calculated, and they are stored and given as output. Here you can see that in the division, the quotient, which is 1, is calculated and stored in A, and the remainder, which is 2, is calculated and stored in B. Now, earlier I have said that if the product result is greater than 255, then the result is split into 2 parts and they are stored in A and B. So let's check that by restarting the debugging. So for doing so, click on this reset tab on the toolbar so that the debugging will restart. We can see that the 2 arrows are pointing to the first location, that is, the debugging process has been restarted. So start debugging by pressing F11. Now let's give the values as 10, that is 16, and another value is also 10, that is 16. And let's check the statement. Place the cursor, taking the inputs, calculating the sum, storing the sum in register, and giving it as output. Again for subtraction, taking the values, calculating the difference, storing the difference, and giving it as output. Here, since the both values are same, so the difference is 0. Now let's check for the multiplication. The values are taken, the product is calculated. Here we can see that the higher byte of the product is stored in B and the lower byte of the product is stored in A. So the statement which I have earlier said is satisfied. In this way, the arithmetic operations are executed in the 8051. So now we will implement a circuit for this in Proteus and check it physically. I stop the debugging and save this file. I have already created a Proteus file on this arithmetic operations. So let's check it. So this is the circuit for the arithmetic operations. Here in the code, I have considered P0 and P1 as inputs. So I have taken the toggle switches to change the input values. And P2 and P3 are considered as outputs. So I have connected the LEDs in order to check the outputs. Now, in order to access the 8051 microcontroller in Proteus, we have to search for AT89C51 in the product library. Now, for accessing the code which we have written in the Keel microvision, we have to copy the hex file and place it in this microcontroller. So for doing that, double click on the microcontroller. In the program file, search for the hex file of the code and open it and click on OK. Now the hex file is added to the microcontroller. Let's give some input values to the program. I have given the first input value as 5 and the second input value as 3. The process for giving value is very simple. Just click on this red button below the toggle switch. and the state of the switch will changes. Now let's start the simulation. Here we can see that the port 2 and port 3 are logic high. That means in the initial stage of simulation, the 8051 is defaulting them as inputs. On continuing, we can see that both P2 and P3 are assigned as outputs, since in the code we have assigned them as outputs. Here we can see the result of the addition, that is 5 plus 3 as 8. And so for the subtraction, 5 minus 3 is equals to 2. And so for the multiplication, that is 5 into 3 is 15. And for division, 5 by 3, the quotient is 1 and the remainder is 2. So in this way the arithmetic operations of 8051 are accessed. Please like, share and subscribe to the channel and hit that bell icon to get notified for the future videos. Thank you.